I'm Ali. In this video, I'm going to talk about land administration. We focus on land administration in Australia. My research topic is evaluating the accuracy of digital cadastral map through back capturing paper-based plan. And in a few minutes, I will present it here. Currently, I'm doing my master at the University of Melbourne, and I did this research under supervision of Dr. Kalantari in University of Melbourne, and I continue my research in University of Illinois with my advisor, Professor Lu. Let's start. At first, I wanted to show you what I'm gonna talk about today. So, as you can see, I will tell you what is my project objective, and then I will introduce my project and talk about the history and background of my project. And I will explain why this project is important and what is interesting about it. Then we go through technical stuff and explain my research in details and present research achievements. At the end, I will conclude the recommendation for further future study, and then after you review this video, you can send me your question by email, and I will try to answer them properly as much as I can. So let's start. First, I'm going to tell you what we're looking for in this project. I aim to explain why cadastral systems play important role in future. I also present the history of land administration in USA and especially Australia. I'm going to introduce DCDB, LeaseCAD, Eplan, and back capturing process. We also learn about compilation, map compilation, and finally I'll explain my method for this research, and I will present the results. So let's go to introduction slides. First, let me introduce cadastral system. The title of this research is evaluating the accuracy of the cadastral system. So, what is the cadastral system? Cadastral or cadastral system is a framework to record, store, and provide comprehensive land information. It is defined as an up-to-date land information system containing a record of geometric description of land parcel, interest in land, and ownership. So, why land administration is important? Land administration is important to principle to make a strategic and operation decision, especially in emergency situations. And to answer how technology plays roles in modern administration, I can say new range of technology such as satellite, digital theodolites, cameras, and digital theodolic devices and internet provide great opportunity for better services in land administration sector. So land administration system should be able to adapt with the new technology. Okay, the next section is need for improvement. Different improvements occurred in the recent history of land administration. I'm going to cite these improvements. The recent structure of land administration system was built by Europeans at 19th and 18th centuries, mostly for land taxation and land rights. Another improvement in this sector happened when the real estate market grew. And due to increasing amount of information for better managing the land records, principle defined a specific structure that now we called old administration system. New administration system usually defined by digital land administration, where recent effort in the process of digitizing paper plan occurred. In new recent changes, principals decided to improve the system after financial crisis and collapse of real estate market. They decided to review the current structure to prevent or predict this emergency situation and crisis. So, what does it mean when we talk about the paper and PDF plan? Our next slide. Uh, as you know, old land administration system was mainly paper-based. By introducing new technologies, land administration tried to adopt with new technology and introduce electronic land administration. Also, former land administration was unable to meet the increasing demand in this sector. So principal tried to introduce the electronic land administration by digitizing paper-based map and introduce the online services. Our next style is digital cadastral database. In this research and my report, you will hear a lot about digital cadastral database or DCDB. So let me explain it. I already explained that the land administration improved gradually to answer new demands and try to use new technology in process of land administration. Simply, DCDB or Digital Cadastral Database is a digital system that can store land registration and land mapping information. In next slide, I'm going to talk about the cadastral system in USA. So for better understanding of cadastral system and its role and potential, first should become familiar with its concept and history. This research reviewed the history of land administration in the USA and also in Australia. In this presentation, I'm going to review them very fast. In the USA, as you can see, different changes happen through the years to improve cadastral system. Like I mentioned, changes in 1980 when the rectangular survey system applied in the USA, or new reviewing after financial crisis. For more information, I explain inclusively the history of U.S. land information administration in my report. So I refer for future study to my report. In next slide, I'm going to talk a bit about financial crisis and why it's the important spot in the history of the land administration. In the last few years, financial crisis has a huge impact on people across the world. It is also a controversial issue among many people who criticize U.S. government for financial crisis because they believe it started by collapse in the real estate market in USA. They believe the absence of federal oversight of land record system in the United States was the primary cause of this problem. They think federal government should predict the recent mortgage crisis by tracking different signs. And this sign can be seen in distressed mortgage or decreasing real estate value across the USA. Many believe that if the USA has a good national cadastral system, it would be in a better position to respond to this crisis. In next slide, I'm going to talk a bit about land administration in New South Wales and also in general in Australia. After USA, in my report, I explain land administration system in Australia by focusing two special states, New South Wales and Victoria. Shortly, I can say in Australia, Land administration is a state government responsibility, and there is no uh, unified organization structure to support all states. Uh, Inclusively, I explain both Victorian and New South Wales land administration system in my report, so I refer you to my report. Now, after presenting background in land administration, let's go to my main part of the research, the accuracy of the uh, plan, back capturing, and why I started this research. Uh, for a start, I'm gonna explain the E-plan in Victoria. A few years ago, the lodgement system in Victoria relied on many manual processes and using large amount of papers, which is inadequate for the current demand. E-Plan as a solution introduced in Victoria to provide fully electronic submitting plan of subdivision. Based on a definition by Victorian Land Registration, the E-Plan file contains all information in a cadastral survey and subdivision plan and includes the following information: survey measurement, dimension of the parcel and interest in land, plan approval status, the survey details, and so more. DCDB introduced a few years before E-Plan project and is formed by compilation of the paper PDF base through the manual process. As I already explained that DCDB is a digital system can store land registration and land mapping information. In our new system, E-Plan has this potential to digitize the process of land compilation in DCDB. Currently in Victoria, by using E-Plan system and through this process, surveyor should submit the map digitally and changes will automatically applied on DCDB. So, what is my project question? So, and why I start to research about back capturing. So, resurveying all former and old subdivision plans with new electronic method and submit them digitally has a huge operating cost. Currently, there is a lot of paper plan with reference mark and boundaries point that can be digitized and submitted on DCDB. So, by back capturing process, I'm looking for an approach to use available paper-based map and digitize them without doing any actual survey on land, which means digital and current available paper-based, which means we're gonna digitalize current available paper and without any resurveying the land. So in this research, at the end, if I conclude that this method has enough accuracy, we can suggest Land Victoria to use available paper plan for updating DCVDB, and the Land Victoria can, and huge amount of saving and saving time and money will happen. So what methodology I use? In this research, I employed experimental simulation as a methodology, which means I try to experience the whole process of back capturing and submit a plan of subdivision and illustrate my observation and analyze the accuracy of the method. For this incident, my supervisor, Mr. Kalantari, provided me two plans related to subdivision of one lot in two separate dates. So in two separate period of time, which means one of them belonged to 1995 and the other was the newer version of the subdivision map surveyed in 2012. So at first, for generating a Eplan file, I need to learn how to use this gap. Eplan file can generate and develop by the software named LeaseCAD. I started by reading program manual, and I learned how I should use LeaseCAD, and then I start to transfer the PDF and paper maps to digital format by using a specific approach. And if I want to explain properly what is this specific approach, I can say example about transferring point, or line, or polygon data, because there is a specific code that you can select them from code toolbar at the top of the software screen, and each point and each line will be marked based on it will be marked with a special codes in process of digitizing map. Creating a plan starts by plotting the reference mark and permanent mark. So the permanent mark, as you know, is where surveyor, it's a place surveyor set the surveying devices like total station on them. In next step, after I plot all reference mark, I start with traverse point and boundary coordinates. I plot all these points by using survey information mentioned on the paper plan. Once all points plotted, we can join the point together by using line. But yes, the points can be joined together by lines. And always should consider that each line must be coded, as I explained to you, by using the specific Eplan coding convention. So let's go to result part. After I transfer all data, I start reading all boundary points coordination and compare them in two specific methods. One, my first method, evaluation accuracy inside each subdivision, and also my second method was observing the accuracy after completing those two subdivisions together. I present the result in three separate tables, which two of them compare accuracy inside each subdivision plan, and finally it evaluates the accuracy of the compiling subdivision plan with four possible compilation approach. So after I finish this comparison and I come up with the table of results, have some recommendation for future study. Actually, for future study, I recommend the result of this research should analyze it with mathematical functions in order to estimate accuracy of the compilation. And also, in addition, this research can be extended by manually adjusting information provided by back capturing, which is I used to prepare the table of the perception measurement. And so for extend this research, we can manually adjust this information with current boundary coordinate in DCDD, and we can generate a new map of, we can generate the new tables, and it shows the accuracy and perception of the this type of compilation. At the end, I think Eplan technology is an excellent tool that Elan administration system should adopt themselves with new technology. And at the end, and you can see in my final slides, my references, and thank you to listen to my presentation. Please send me your question to my email. I'm happy to answer them as much as I know. So, goodbye.